As the landscape of U.S. research funding faces unprecedented upheaval, the National Science Foundation (NSF) is bracing for significant budget cuts and layoffs that could reshape the future of scientific inquiry in the country. Recent developments suggest that up to half of the NSF's workforce may be laid off, a drastic measure triggered by a combination of budget freezes and a federal mandate for rapid downsizing. The implications of these actions are profound, potentially jeopardizing the agency's ability to support essential research across various scientific disciplines. The NSF, a key player in the federal funding ecosystem, has been operating under a short-term continuing resolution set to expire on March 14, 2025. The ongoing budgetary uncertainty stems from a projected multi-billion-dollar shortfall linked to the CHIPS and Science Act, coupled with an executive order mandating significant staff reductions. Senator Ted Cruz, Republican, Texas, publicly criticized the NSF's spending practices, alleging that over $2 billion had been redirected to diversity, equity, and inclusion (DEI) initiatives, framing this as a misuse of funds. This political rhetoric has set a combative tone for discussions surrounding NSF funding and priorities. Reports indicate that layoffs targeting probationary employees have already commenced, with some staff members receiving mere minutes' notice to vacate their offices. As the NSF grapples with the reality of these cuts, its ability to award grants, a lifeline for countless researchers, hangs in the balance. The agency has already paused new grant awards, leaving many scientists uncertain about their financial futures and the viability of ongoing projects. Historically, the NSF has funded approximately 25% of all federally supported basic research, providing crucial support to over 350,000 researchers, educators, and students across 1,800 institutions. However, following the Fiscal Responsibility Act spending caps in 2024, the NSF's budget was slashed by 8%, leaving the agency approximately $6.6 billion short of its funding targets. The possibility of further cuts, with the annual budget potentially plummeting from around $9 billion to as low as $3 to $4 billion, raises alarm bells about the future of American scientific research. The recent American Association for the Advancement of Science (AAAS) meeting, attended by thousands of scientists and advocates, encapsulated the prevailing mood of uncertainty. In the wake of workforce reductions across various federal research institutions, including the National Institutes of Health and the Environmental Protection Agency, attendees expressed feelings of anxiety and fear about the direction of U.S. science. AAAS CEO Siddip Parikh acknowledged the turmoil, stating, "We are gathered in a moment of turmoil. It's turmoil." The sense of confusion and disarray was palpable, with researchers reporting a pervasive atmosphere of chaos within their institutions. As researchers navigate this challenging terrain, many are contemplating their futures and the potential for relocation to more stable environments. International scientists are expressing concerns about continuing their work in the United States, underscoring the potential long-term implications of these funding cuts on the country's research ecosystem. The ongoing political climate has fostered a growing desire for collective action among scientists, many of whom view collaboration as essential to protecting the integrity of American scientific research. Amid these challenges, grassroots movements are beginning to emerge. The Union of Concerned Scientists has initiated a campaign to gather signatures opposing the current administration's actions against science, accumulating over 50,000 signatures. Additionally, a rally titled "Stand Up for Science" is being organized to mobilize support for the scientific community in response to the ongoing threats. As the NSF prepares for the potential fallout from these budget cuts and layoffs, the broader implications for U.S. scientific research remain uncertain. The convergence of political pressures, funding dilemmas, and workforce reductions creates a precarious situation for researchers and institutions alike. The next steps taken by the NSF and lawmakers will be crucial in determining not only the future of the agency but also the global standing of U.S. research in an increasingly competitive landscape. With China poised to become the world's leading R&D spender by 2030, the urgency to address these challenges cannot be overstated. As scientists and advocates rally to defend their work, The collective voice of the research community may play a pivotal role in shaping the future of science in America. In a significant breakthrough for agricultural biotechnology, researchers at the University of Queensland have successfully introduced genetic material into plants through their roots, potentially revolutionizing crop improvement processes. This innovative approach promises to drastically reduce the time and cost associated with developing new crop varieties, which traditionally involves lengthy and complex breeding cycles. The findings published in Nature Plants highlight the potential of nanoparticle technology in enhancing crop yields and quality, addressing pressing global food security challenges. Professor Bernard Carroll, a leading researcher in the study, explained the limitations of conventional methods. Traditional plant breeding and genetic modification take many generations to produce a new crop variety, which is time-consuming and expensive. He stated. His team's novel technique utilizes nanoparticles designed by Professor Gordon Sue's group for medical applications such as vaccine delivery to facilitate the transfer of genetic material into plants. The nanoparticles are coated with a protein that loosens the rigid cell walls of plant cells, allowing the nanoparticles to penetrate and deliver synthetic messenger RNA/mRNA into various plant species, including Arabidopsis, a model organism widely used in genetic research. It was surprising that rather than delivering all of its load in the first cell it entered, the nanoparticle traveled with water through the plant, distributing the mRNA as it went, Carroll noted, underscoring the method's efficiency and potential for widespread application. The implications of this research are profound. By enabling the rapid expression of specific traits, the technology could address issues such as crop flavor and quality without the need for extensive crossbreeding or genetic modification processes that can take decades. With further improvement, the technology could potentially be used in the future to produce new crop varieties more quickly, Carroll added, indicating a future where agricultural innovation can keep pace with growing global demands. The nanoparticle technique has already been patented by UQ's commercial arm Uniquest, which is actively seeking partnerships to advance this promising technology. As researchers continue to refine this method, it holds the potential to transform not only how we approach crop development but also how we ensure food security in an increasingly uncertain climate. Looking ahead, the agricultural sector is poised for significant advancements as these technologies develop. The intersection of biotechnology and agriculture will likely yield new solutions to the challenges posed by population growth, changing diets, and environmental pressures. As this research progresses, it may pave the way for a new era in sustainable farming practices, ultimately revolutionizing how we grow and consume food. In a groundbreaking study, researchers from the Andel Institute in Michigan have uncovered compelling evidence suggesting that cancer risk may be established even before birth during fetal development. Published in the journal Nature Cancer, this research shifts the paradigm of cancer understanding, traditionally viewed as a consequence of aging and genetic mutations, by highlighting the importance of developmental epigenetics in determining an individual's susceptibility to this complex disease. The study identified two distinct epigenetic states that emerge during the development of genetically modified mice, each associated with varying risks of cancer. One state correlates with a lower lifetime cancer risk, while the other is linked to a higher risk. Notably, the type of cancer that may develop also differs according to these states. If cancer does develop in the lower risk state, it is more likely to be a liquid tumor such as leukemia or lymphoma. If cancer develops in the higher risk state, it is more likely to be a solid tumor such as lung or prostate cancer, the researchers concluded. At the core of this research is the gene TRIM28, which appears to influence these epigenetic patterns associated with cancer-related genes. The findings indicate that the foundations of cancer risk are laid during early development, suggesting that factors beyond genetic mutations accumulate over time, play a crucial role in cancer etiology. J. Andrew Pospizilik, the director of the Center for Epigenetics at the Andel Institute, remarked, "Because most cancers occur later in life and are understood as diseases of mutation, there hasn't been a deep focus on how development might shape cancer risk. Our findings change that. Despite the transformative nature of these revelations, the researchers emphasized that further investigation is necessary to explore potential treatment avenues arising from these insights. As the scientific community digests these findings, they open new doors for understanding cancer risk and prevention strategies, potentially leading to earlier interventions based on epigenetic markers. In a parallel vein, the healthcare landscape continues to evolve with technological advancements. A recent AI summit in Paris highlighted the growing role of artificial intelligence in the medical field. While AI has already made strides in diagnostic accuracy, particularly in medical imaging like mammograms, experts caution that it should complement rather than replace human expertise. Dr. Gregory Lenksner, a radiologist in Paris, noted AI can detect suspicious microcalcifications on mammograms, ranking their severity on a scale of 1 to 10. In everyday practice, the technology offers valuable confirmation. As AI becomes more integrated into healthcare, its applications extend beyond traditional diagnostics. Innovative projects such as an AI-driven robot designed to provide tailored guidance on sexual health and HIV prevention are emerging. This initiative, led by South African-American company Audera, aims to break down barriers surrounding taboo health topics by offering users anonymity and support. Meanwhile, advancements in cancer diagnostics are also underway. Researchers at MD Anderson Cancer Center have developed a novel biomarker that predicts the aggressiveness of brain and breast cancers. Their work, published in Science, focuses on the enzyme RNA polymerase II API and its correlation with tumor proliferation. This breakthrough underscores the potential for genomic technology to enhance precision oncology approaches, providing more accurate prognostic tools for clinicians. As these groundbreaking studies and technological innovations unfold, the intersection of genetics, epigenetics, and artificial intelligence promises to redefine our understanding of cancer and its treatment. The future of cancer research and healthcare appears to be on the brink of significant transformation, paving the way for more effective prevention strategies and personalized treatment options. With continued research and technological integration, the hope is that we can better address the complexities of cancer and improve patient outcomes in the years to come. In an era where artificial intelligence (AI) is becoming increasingly integral to healthcare, recent findings have raised significant concerns about the cognitive capabilities of older AI models. A study published in the BMJ has revealed that, akin to human aging, these AI systems, specifically large language models (LLMs) and chatbots, exhibit signs of cognitive decline, which could have profound implications for their reliability in medical diagnostics. As healthcare professionals increasingly turn to AI for assistance in diagnosing conditions from X-rays to complex medical histories, the insights from this study prompt a re-evaluation of the extent to which these systems can be trusted. The researchers conducted tests using the Montreal Cognitive Assessment (MoCA), a tool typically employed to assess cognitive impairment in humans. The study analyzed several widely used chatbots, including OpenAI's ChatGPT and Alphabet's Gemini, and found that while newer models like ChatGPT version 4 performed relatively well, older versions such as Gemini 1.0 scored significantly lower, indicating a decline in cognitive function. The implications of these findings are critical. The authors of the study noted these findings challenge the assumption that artificial intelligence will soon replace human doctors, highlighting that the cognitive impairments observed in these AI systems could undermine both their efficacy in clinical settings and patients' confidence in their diagnoses. Tasks that require visual abstraction and executive function emerged as particular weaknesses, suggesting that reliance on older AI models in these areas could lead to misdiagnosis or oversights. While the study's authors emphasized that the results are observational and not directly comparable to human cognition, they pointed to a significant area of weakness that could hinder the deployment of AI in healthcare settings. This revelation not only raises questions about the long-term viability of older AI systems but also opens the door to a potential new market for neurologists assessing AI systems that show signs of cognitive decline. In conjunction with these findings, the field of healthcare technology continues to advance. At the recent AI Action Summit in Paris, Experts showcased a variety of AI-driven projects aimed at revolutionizing medical diagnostics and patient care. For instance, AI applications are already playing a pivotal role in medical imaging, assisting radiologists in detecting anomalies in mammograms. Dr. Gregory Linksner, a radiologist in Paris, explained that while AI does not surpass human capability in detecting issues, it serves as a valuable tool for confirmation, helping mitigate the risks of oversight due to distractions or fatigue. Moreover, AI is being leveraged to address sensitive subjects like sexual health and HIV prevention. Companies like Audera are developing AI systems that provide tailored guidance for individuals seeking information or assistance in these areas, breaking down barriers that have traditionally hindered open discussions. As the landscape of AI in healthcare evolves, the recent launch of Google's Gemini 2.0 Flash model promises to enhance user experience with faster response times and improved accuracy. This new model, integrated into Google's applications, reflects the ongoing innovation in AI technology. However, the potential cognitive decline of older models serves as a reminder of the challenges that accompany such rapid advancements. Looking ahead, the intersection of AI and healthcare will undoubtedly continue to develop, with new technologies offering exciting possibilities. Nevertheless, it is essential for developers and healthcare professionals to remain vigilant about the limitations and reliability of these systems, ensuring that as they integrate AI into patient care, they do so with a comprehensive understanding of both its capabilities and its shortcomings. As we advance, the dialogue surrounding the ethical deployment of AI in medicine will be critical to building a future where technology complements human expertise rather than attempting to supplant it. During a recent visit to Boston, Lee Chang-yoon, the first Vice Minister of South Korea's Ministry of Science and ICT, underscored the importance of bolstering U.S.-Korea scientific collaboration amid a rapidly evolving global technological landscape. The visit, which took place from December 12 to 14, aimed to engage with key figures within the American scientific and technological community and explore avenues for enhanced cooperation, particularly in the realm of biotechnology and nuclear fusion. Meeting with prominent leaders such as Marcia McNutt, the president of the National Academy of Sciences, and Sudeep Parikh, CEO of the American Association for the Advancement of Science, Vice Minister Lee gained insights into the current science and technology policy directions under the Trump administration. The discussions revolved around how to leverage shared interests to foster deeper scientific partnerships between the two nations. As part of his itinerary, Lee also toured critical infrastructures within Boston's renowned biotech cluster, including Labs Central and the Cambridge Innovation Center (CIC). The Ministry of Science and ICT emphasized the need to fortify South Korea's domestic biotech innovation ecosystem while simultaneously facilitating the global commercialization of promising biotech technologies. This dual approach aims to elevate South Korea's position in the competitive global biotech arena. In addition to meetings with American counterparts, Vice Minister Lee convened a gathering with Korean American life scientists, which included members from the New England Biomedical Association and the Korean American Society of Biopharmaceuticals. During this meeting, the Korea Institute of Science and Technology (KIST) outlined plans for establishing a center in Boston, which could serve as a pivotal point for scientific exchange and collaboration. Reflecting on the significance of the trip, Vice Minister Lee stated, "Through the Boston trip, I was able to confirm that the U.S. scientific and technological community recognizes the importance of U.S.-Korea scientific and technological collaboration and supports it." He further urged Korean American scientists to take a proactive role in fostering ongoing cooperation, highlighting the necessity of continuous high-level communication with the Trump administration to maintain momentum in collaborative efforts. The implications of Vice Minister Lee's visit are noteworthy. As technological advancements increasingly dictate geopolitical dynamics, strong scientific partnerships can serve as a foundation for broader diplomatic relations. By fostering a robust U.S.-Korea scientific alliance, both nations stand to benefit from shared innovations that could address pressing global challenges, from health crises to climate change. Looking ahead, the commitment to enhancing scientific collaboration appears set to continue. As the global landscape shifts, both the U.S. and South Korea will likely seek to navigate emerging technological frontiers together, leveraging their combined expertise to address the complex challenges of the future. The developments from this visit could mark the beginning of a new chapter in U.S.-Korean relations driven by the shared goal of scientific advancement.